What if the tool you've been using every day for data science is actually holding back your creative freedom? In today's episode, we are sitting down to break down Marimo, the reactive Python notebook that's reimagining how data teams, researchers, and engineers work. Here's what we're diving into today. The flaw in traditional notebooks. 1 plus 2, I would have thought would be 3. But
I would agree, but the answer is 42.
Next-gen reactive UIs.
Because I could say, well, let's take that slider value. I got to run the cell, but now whenever I update this slider,
Heavy-duty compute.
You hit this button over here, GPU, you click there, save from the start.
Challenging industry monopolies.
Your coordinate and the zoom level, that changes.
Awesome.
But also if I click on the map.
And finally, AI control and remote workflows.
I'm gonna hit enter now. My hands are off the keyboard for a dramatic effect, but also to really show that. Yep, click there.
Let's dive in. Vincent, first full-time hire at Marimo. Welcome on Geospatial FM.
Hi, thanks for having me.
What is your favorite keyboard?
Right. So I do have this hobby that became a bit unhinged. If you have RSI issues, what I don't want to say is that any of these keyboards is the best. But what I will say is if you're looking for something that's way more ergonomic for most hands and for most problems, a sensible default would be this guy. This is the Glove 80. It's one of those keyboards that has a fancy key well. The distance horizontally is like really small. You always move your fingers up and down. You never do the wiggly wrist movement. So for a lot of use cases, this is a sensible default. If you have RSI issues though, before you invest in big expensive keyboards, my best advice is to actually go to the gym.
Yeah, it's amazing. I've never seen them actually broken up into 2 different pieces for each hand. It makes it feel like you could have them at different heights.
I have met people that mount them on their chairs. That definitely exists. One thing I will say though, that you can probably imagine that you have to move both hands to the center. And then, if you move them to the side, your chest just opens up, right?
Yeah.
You can sort of physically do that now. And you can also imagine you automatically stand up straight. Yeah. So even if your concern isn't so much your wrist or your hand, just the fact that you can open up your chest is already pretty good. Yeah,
I'm opening up my chest now.
Yeah,
I'm
so just
feeling better. Just
thinking about it, your shoulders relax and stuff, So, and also one thing, just a little comment, right? Your hands are symmetric. Why isn't your keyboard?
Great. Everyone is now Googling strange keyboards. Perfect.
Exactly.
Okay, so first serious question then. Apparently it's around half a year into Coreweave having acquired Marimo.
Yes.
Specifically, given that GPUs are the flavor of the year, I don't know. How are these GPUs useful?
So from the perspective of I'm an individual, what actually changed when we joined Coreweave? So we are still, I think we're 8 or 9 people. It depends a bit on how you count the full-time or part-time people, but we're still a really small team. So the main thing that I noticed when we got acquired is that Slack suddenly became a lot bigger. So the new Slack is close to 1,000 people. Old Slack was close to 8. So the first thing you do in your first week is just exclude yourself from irrelevant Slack groups. And that's still, I wouldn't say a challenge, but it's still an activity. Just make sure there's not too much noise in Slack. That's the main thing that really changed, because us as a Marimo team, we're still kind of a close-knit group. And the rest of the company is also aware of the fact that we are probably the fastest growing Python project right now. Our download numbers on average grow 5% a week. So, we are super
that is
growing.
A lot on an annualized basis.
Yeah, so
wow.
There's a bit of a joke that there's been this edict from above basically saying leave them alone. They're doing something right within the group. We don't want to interfere with that too much. Please let them do their thing. So in a lot of ways, the roadmap hasn't really changed that much. We still have dreams that we like to chase, and we implement features we'd always want to have. One thing that is a bit different is at the start of the year you can make plans. And then the agentic thing takes off. Okay, we have to change our plans a bit. We do have to listen to what's happening in the ecosystem a little bit more, just because things are changing so fast. But that's more the age we live in than Coreweave per se. If I were to point at anything that Coreweave has changed, is the fact that they are a company that do have a lot of GPUs and compute power in general. They are also a cloud provider that have ambitions that go beyond just GPU stuff. Historically, I think it's pretty accurate to say that they've been a provider for GPUs for the training purposes of some of the bigger labs in the US. But they are, of course, also keen to have smaller companies and to be a more generic cloud provider. And for that, it becomes useful if there's maybe a generic data processing tool that is within their ecosystem. And you can imagine that's where we fit in. So one thing that we've been able to do is we've been able to make this. So Jupyter is this open source notebook. And then Google made this thing called Colab, which is, you could call it a reskin with some extra features. But that reskin does give you a free GPU. And that's always been a reason for people not to use our version, which is called molab, which is basically Marimo's version of Colab. But we were never really able to offer a free GPU for educators. Thanks to Coreweave, we can. So there's like a few of these things that we can now do. And as far as roadmap is concerned, yeah, like the people who are now working on like GPU features and free GPUs and stuff, that does take away some of the attention from open source. And if I can make one joke there, is like, oh yeah, offer the world free GPUs, they said. It will be fun, they said. Suddenly we have like some full-time people doing nothing but fraud detection because people are using these GPUs for things we don't want them to use them for. So crypto miners and things like that, right? Like, so we really have to figure, like, a lot of fraud stuff is basically what I'll say is happening under the hood there. But at the same time, we do like to think that, hey, that product can be extremely meaningful for students. Right, so we'd love to have that be a good entry point for Marimo for educators who are interested in doing experiments, but that do require a GPU. And the GPU that you can get for free now on molab is pretty darn beefy. Like it's like 96 gigabytes of memory. Like it's a chunky boy that you get there. So like another thing I would like to mention on that, like I've personally always been of the opinion of, I don't mind working on a shitty machine because that way I write my software in such a way that I'm just a bit aware of the compute, right? Like it's pretty good software practice. But some of the machine learning stuff you just need a GPU for these days. And one thing I have found, which is pretty interesting, is that because I allow myself the creative freedom of a GPU now, I actually start approaching problems just slightly differently. It's a super nerdy computer science thing. If I say the traveling salesman problem, does that ring a bell?
Yes.
It's a classic. It's a bit of a classic one, right? So
that comes up in geospatial education. Yep.
Yeah. So it's a bit of graph stuff, you know. So okay, Vincent has a GPU now. Okay, like how would you approach the traveling salesman problem differently now that you've got a GPU? Because a GPU, if you think about it, it's actually kind of a dumb CPU. There's just lots of them. So what I need to do is like chunk up my problem in such a way that I could give it to like lots of little dumb CPUs massively in parallel. And like a very fancy algorithm would do a thing like, okay, we're going to look for edges that we might be able to swap. It's like the 2-opt algorithm. So if there's ever a crossing path in a TSP, you almost immediately know like, okay, that's not going to be optimal. I need to swap paths around. That's like less distance. And a fancy algorithm would say like, oh, if there's a 2-opt swap possible, maybe around that vicinity, I can do a 3-opt swap. So I'm going to do that. I'm going to do that sequentially, try out a 4-opt swap, search around that space, and do this a whole bunch. But all that stuff happens in sequence. With a GPU, you can also just say, take every pair and see if there's a 2-opt swap possible. Boom. And it just, or if it's still quadratic, so if you're like 1,000 cities, you can't do that. But then you do a windowed approach, you figure out some sort of trick to just fill up the entire memory of likely pairs that could be improved. And, you know, within like half a second, you've checked all the possible pairs, and the entire graph is 2-opt.
Okay, so I found a segue partway through what you were saying. You mentioned Jupyter. I think that's because I've been aware of Jupyter Notebooks for, I don't want to say since 2020.
That's relatively recent. That's relatively recent. Jupyter's been around for a while.
Right. So I think I found out about Marimo only at New York Climate Week last year.
Okay, could be.
So, you know, if my trajectory is anything to go by, possibly Marimo is less well known than Jupyter. So
that's safe to say. That is safe to say, yeah.
Could you make the contrast between the two based around something that Jupyter always gets wrong?
Right. Oh, yeah. So we had this pre-call, and I hinted at that. So let me start maybe by saying a thing that Jupyter does right, because one thing to remember is that Jupyter has been around for a while. Definitely well over a decade. I'm inclined to say maybe even longer than 15 years. And the history of it is it all started from the shell, but then people said, oh, we can move some of that interactivity to the browser. We can show charts and do all sorts of cool things in the browser. That would be nice. And then some people said like, oh, it might also be nice if it isn't just a Python thing. If we have Jupyter, they could maybe also do Julia and R. Jupyter. That's kind of where the name came from. And then people actually moved on and also made Ruby kernels and C++ kernels. And the whole point is that we design something that has that interactivity, but can still run in the browser for all sorts of different languages, like be nice and open. That's always been kind of the goal at Jupyter. And then there's been like a reskin, something called Jupyter Lab, where you can have multiple tabs open with multiple notebooks. And, the project grows and grows and grows, but that was a starting point. We want multiple languages. Marimo says, no, we think people want to use Python in notebooks mostly. So we don't really care about Julia. It's a really cool community, but Marimo is going to be just for the Python people and for the Python crowd. We really want to make the experience the best for the Python person. Now, we do some tricks such that you could also run SQL if you wanted to, and you can also have Markdown, and we have all sorts of fancy things with browsers that we can do. So there's a gamepad in the back there. Like you can hook up a gamepad to a browser gamepad SDK, and through that you can make a widget that can interact with, So we do a little bit of JavaScript that way, but it's mainly there to serve the Python experience. But we are in a browser, so we can pull off some JavaScript tricks. So that's just the introduction. Like I do want to be honest about the thing. Like Jupyter did a lot of good. Like it was one of the first proper interactive environments. And if I think about just in machine learning, right? So many of the algorithms, got discovered, got fooled around with in that Jupyter environment, because you need charts to be creative sometimes, and you can't do that from an IDE. It's just not the way it works. So Jupyter did a lot of good. It's just sort of the starting point. It's just that at some point, the founder did start noticing some downsides of Jupyter. So one downside is that if you want to have all the languages supported, then you need to serialize the disk in a way that's language independent. Okay, so people chose JSON. And people then also figured, like, we could maybe also store the output then, because that way we can render the notebook and we don't have to re-render it again every single time. And then, okay, but that means that if you throw that into Git, then you're going to get these large blobs of image as part of your notebook serialization thing. And, if the image changes, you've got like a megabyte maybe of Git diff. And that's now in your Git chain, right? So there's ways around it, right? But you can also see that from this decision where we want to support multiple languages, there are also going to be some consequences. And Marimo wants to avoid a lot of that. And it can, because it's saying, well, we just do Python. And one thing I could do now is I could maybe also share the screen, because you've used Jupyter yourself as well, right?
Yeah.
Okay, then we're going to play a fun little game.
There's a link also, given that there's a geospatial context here. You can use notebooks in the dominant geospatial software from Esri ArcGIS Pro. So at least people who come from a regular standard Esri technician background might be familiar with what you put on the screen here.
Sure. Well, I mean, this is Jupyter. People are probably familiar with the interface, but the main thing that people probably recognize is we've got these cells, right? So for those of you that are listening and are not sort of watching along, I've got this one cell with the number 1 in front of it, A is equal to 1. I've got this other cell with number 2, B is equal to 2. And now I'm going to add the two numbers together. And a question for you, what's the output going to be?
1 plus 2, I would have thought would be 3, but
I would agree, but the answer is 42. And the question is, how could this be, right? Because it says the number 3 here, and it feels implied that like this cell and that cell happened before this cell, so why is 42 coming out? And the answer is because A is actually equal to 40. So what I can do, and I'm going to be really, really cheeky here, I'm going to restart the kernel. So I'm going to restart this notebook. I'm going to throw this away. I'm just going to write A is equal to 40 here in this cell below. Notice this 1 here.
Yep.
Notice this 1 here. Okay.
I'm
now going to delete this cell. I'm going to delete this cell. I'm going to run this one. And
oh no.
Yeah, and so okay. What am I alluding to here?
Oh.
This is particularly cheeky what I'm doing here. Like I'm setting the stage in such a way to fool you. This is not necessarily representative of something people do in their day-to-day. But the one thing I do want to point at is the stuff you see on display is not a reflection of what is actually in memory right now. And that's an issue, because another thing you can do in Jupyter is you can have one cell that says A is equal to 1 and another cell that says A is equal to 40. And hopefully the number that's in front of the cell is an accurate depiction of the order in which things ran. But that's not even a guarantee either. So you're going to have to teach yourself some really good habits with all of your colleagues to make sure this doesn't go awry, right? Wow. So if I think about like all the bugs and all the errors that happen when Bob sends an email to Greg with or a Slack message with with a notebook in it, it's Jupyter, and this is the stuff that can go wrong. You get this, it works in my machine, but it works on my machine in my notebook, kind of a phenomenon.
Gotcha.
Right?
Gotcha. Yeah.
So again, still interactive environment, still does a lot of cool things, but this is painful. And the whole point of Marimo is to prevent this for the Python people. Because if you prevent this, and I don't know, What if there was like a big fat error in your face that said like, yo, dude, this is going to lead to an error. Like, don't do this. That would be good software practice is the assumption. So what I'm just going to show you now is the same thing, but I'm going to do it in Marimo. So I'm going to do UVX. That's for the UV people. I can do Marimo at latest, and I can do something like edit podcast.py, because we're in the podcast right now. Then on this other display, this thing opened up, and sure, let's also make sure this is nice and compact so it fits on display. Okay, we still Marimo, we still have cells, but now I'm going to do A is equal to 1, B is equal to 2, and I'm going to do A plus B. So far, so good. I'm going to try to set A to 40, and I get an error. Because we're saying, like, look, you're trying to redefine A.
Perfect.
That's no bueno. We don't like that. So we have a mechanism to prevent that behavior. And given that we have a mechanism to prevent that, we can also start doing things a bit differently. Because one thing I can now do is I can change this to one cell. I just, as you can see, this is the cell before, at a 0. It's yellow now. It changed color. So
you need to run it again.
Yes. And when I do, oh, A, yeah, okay. A is defined here. So we got to, there we go. So, okay, we're going to make it 100 now, hit play. Yeah. And when I do, that cell down below can automatically update.
There we go.
So the big picture thinking here is that, okay, from the perspective of this cell, right? I need A and B. So I can't do anything unless A is around. Like, where's A? Okay, let's look. Oh, it's in this cell. Okay. So this cell becomes a parent of that cell. And this cell also becomes a parent of that cell. So you could say that it's kind of like a compiler step. We look at all the code in all the cells, and then we figure out in what order the cells have to run. And then we can play this game of, well, if I ever change a cell, all its children also need to update.
Yeah. Okay, right.
And
as an innocent, slightly less skilled developer than you, Vincent, I would have assumed, I think a lot of people probably would have assumed that those kind of errors wouldn't be made by Jupyter, because it just looks like it's an easier way to interact with an IDE or with idle, good old idle from Python. It just looks like it breaks up all of the lines of syntax into different cells. But the fact that Jupyter didn't make them all act cohesively, I'm glad that Marimo's come along and solved that at least.
Well, I mean, so, and again, like, we should be a little bit respectful there. Like, it's hard for Jupyter to do something like that because, we have to support all these languages. And all these different languages have different assumptions and different ways of working. So a cell is just a thing that runs at some point, and then it's in memory. So, given that that's your goal, I mean, it's fine. Like, I get where it comes from. But the really cool thing, if you do this for Python, is you can be very specific, and we can do very Python-specific things. But one thing I can also do now, and that's, I think, the real kicker that really get people hooked into this, is you're going to notice that I have this Marimo library as well, right? And that library has UI elements. So what I can do is I can just add a little slider, right? That's a slider, that's a variable now. But that variable, like 2 variables added together, that just renders as a string. But I'm in the browser, so why can't I have a variable that just renders as a UI element? Oh, and what I can then also do is I could say, well, let's take that slider value. And now what's going to happen is whenever I update, sorry, I got to run the cell, but now whenever I update this slider,
awesome.
all the cells below it can update. And also, just to sort of get the dream started, that's just a slider. We can come up with any user interface element that the browser
immediately I'm thinking of a map. Yeah.
Yes.
Okay. Yeah. Okay.
Yes.
Okay. You sparked the geospatial industry's imagination right there.
Yes. But before, one thing I do want to mention, because I hear a question in the back of the audience. This is cool because this is all like lightweight compute, right? Suppose we have like a heavy data set, then you don't want slider move cause like minute of compute to happen. You can also run this on cell change behavior as lazy. So now if I were to make a slider change here, these 2 cells become stale and I would manually have to run it. So
perfect.
You do have that control. You can also make user interface elements with buttons that say like only run the code if someone clicks the button, make forms and such. So we're also still just scratching the surface here, but this is kind of the dream. You can now mix and match. You can kind of get the Streamlit thing. You can also make dashboards. There's tricks so I can like hide all the code and only show the UI elements that you've defined, and I can deploy this as a web app. But we like to think that this just sparks more creativity, and it's also safer because of the mechanism that I just described.
you're immediately making me think of, I don't know, a map of countries, and you've got the population per country. You move the cursor over, and it shows up or it passes that value through to the next cell. The coordinates, anything. Yeah. Okay.
Yes.
Wild. Okay, so I guess I wanted to that the inputs you've given so far are making me want to sort of step up or go to a higher level and look at things from a
Sure.
broader
So
perspective.
while you're doing that, I'm just opening
Yeah.
up an example of the map.
So, I mean, in the sort of the modern data team, if you like, starting with the data engineer, data analyst, machine learning engineer, you've got like the practitioner roles. There's an architect, but then there's also the ops roles, if you like, the ones that maintain the infrastructure, for example, to keep the ML pipelines running, keep the platform running that the data engineer uses. Where do you locate the Marimo user amongst those roles?
A few things about that. So in order to explain where Marimo sits, I have to show one feature, and then it becomes very clear where it sits. So I'm going to import scikit-learn now. It's just a machine learning library. People might have heard of it. I'm going to hit run. We immediately detect that a package is missing. So there's none of that like %sign pip install stuff. I can hit install. And the environment that this notebook is now running in, that now installs scikit-learn. If this was in a virtual environment, it would install it there. But this brings us to the topic of dependencies in general and like how you might deal with that. Because all these different personas that you just mentioned, they have different concerns. The data scientist wants this package to run, and the IT ops person just wants code to run sanely as code, right? So they have slightly different concerns about what a notebook should do. So one thing I'm just going to quickly show. So we call this podcast.py, right? Yeah. So this entire Marimo notebook is a Python file. Every cell is just a function that's decorated. So a bunch of magic happens in this Marimo app. You are not supposed to touch this file manually, but if you're working inside of a Marimo notebook, this is the output. And at the end, we've got this Python thing, if name is main, run the app. But okay, it is still just a Python file. So you could construct this in such a way such that, oh, this file is just a normal Python file. We just run it through the command line as normal. That's the thing that you could do. So ops people immediately kind of go, okay, yeah, we like that better. Then we have to download this separate Python package in order to be able to even run it. But then I'm also able to do something extra fancy, and that's what engineers also love. I'm able to add this sandbox flag to that notebook. It's going to start up again now. And it's going to look like pretty much the same. And I can also just refresh here, and let's take it over. There we go. Again, we detect that a package is missing. Again, it's going to get installed. It's also installing MB format. For some reason, that's also that's a setting. We can talk about that later. This takes a long time to actually install. But what I can do is now open up a new tab. And again, open up that file, podcast.py. And you're now going to notice that a bunch of extra information got added on top. So the Python requirement is now added, and the Marimo requirement and the scikit-learn requirement is added. And this is a hard pin of a version. So why does this matter? Well, now this file doesn't need a separate requirements.txt file anymore. And there's this thing you could do uv run and then points to any Python file. And if it has that metadata information, it's going to make a temporary virtual environment, install all the dependencies, the script will run, and it's done. So it's installing now. That's that scikit-learn thing. It's importing it. That's why it's taking a while. But at some point, we could also add a print statement to really confirm that it's actually doing the thing. Print hello world. Hit save. Oh, run it. Sure. Hit save. Hello world. If I were now to go back here, I'm going to run this one more time. Hello world. There we go. Right. So you can run this as a modern Python script. So again, all the personas, they care about different things, but they all have something that they really like about this. And then the final so all the ops people, engineer people, they're kind of happy with this change, right? Because it's just a Python file.
Yeah.
The one feature that and it's also because it's Python in a notebook, the machine learning person likes it, and there's charts and all the libraries.
Yeah.
The one archetype you also mentioned is the analyst. And for them, we've also got this fun little feature. I do need to check. The fancy way to do this is I think I had a Marimo demo folder here, and that had this db.sqlite file. So I'm just going to see if I can copy that because what we've got here is a sidebar, and you can attach things like remote storage, so like S3, do Google Drive, but you can also attach databases. So in this case, I'm going to do SQLite, and let's see if this works. I think it needs to. Okay, so I'm going a bit of a nerdy thing, but I will need to have the full path for that to work. So pwd, there we go. So I'm just going to add that there. SQL db.sqlite run. This is making a database connection, and a really cool thing now is in the sidebar over here with the variables. You can see that there's a SQLite database. I think I misspelled it. Yeah, data.sqlite. That's the thing. So data.sqlite. Okay. And okay, there's tables in here. I can hit plus, and lo and behold, we have a SQLite engine that is actually, go away. I have to install polars because when we run SQL, we always get a data frame in return. You get a very fancy widget that allows you to explore the data set. So
awesome.
There's a search bar here. I could look for Fridays, and it starts. Yeah, there you go. Thursdays. This will look for all the strings, right? So we have an interactive widget. This is something you can also put in a web app. And there's an export here, so people can download this as a CSV. And this will also work with DuckDB and you name it. But you can attach your own SQLite engine. But the really cool thing is you get a data frame back. That's just like a normal Python data frame. So if I open up, this is a polars data frame. So if I wanted to make charts and stuff, I could just do that. That's what a lot of analysts also like.
Yeah. Okay. All right. So genuinely, it does sound like you're satisfying things core to several of those roles that I mentioned.
But for vastly different reasons. And that's the funny bit. Like they all care about a different thing in Marimo. That's like the thing that people don't always recognize.
Okay. Yeah. All right. So I guess what you're saying is you can make a credible case for it being it playing nicely in a professional developer or analyst or machine learning ecosystem.
Yeah. So I don't know if I can name all the companies, but you can definitely imagine some of the apps on your phone. Those companies have started using Marimo, and they like what I'm doing now with you is also something I'm doing with like the head of data at a phone app company.
Wow, awesome. Okay, all right. So I think we got a segue to the next question again amongst your response there. You mentioned scikit-learn, so I'll use that as a way to have you begin talking about what you've done for some scientific disciplines, maybe just one, chemistry, for example, physics, using Marimo.
So there's, I guess like one way to explain that is to also just show you this map widget, and then like that's a nice segue to like what we do.
We can skip to Geospatial too.
yeah. Well, we're gonna do. It's a Geospatial podcast. We gotta mention it. So one thing you can also do inside of Marimo is you can add your own widgets. So there is this library called Open Layers. It also has features that work in Jupyter. But there's now thankfully also a spec called Anywidget. And my colleague Trevor has made this. Anywidget is a specification that lets you make a widget that will work in every single notebook ecosystem. So it'll work in VS Code notebooks, on Colab. It'll work on Jupyter, in Marimo. This is now a new specification for you to make custom widgets that just work everywhere. The old specification, IPyWidgets, works wonders inside of Jupyter, but it works very poorly in Colab. Support can vary everywhere. So there are these projects now, like Open Layers, that just say like, oh, this is a map. And you know how you can update the slider and then a cell below updates? I can now move the map, and what you're going to notice the center coordinate and the zoom level, that changes. Awesome. But also if I click on the map, that coordinate where I just clicked is also something that we can track. And then cells can propagate and update and do all sorts of things based on what you just did. So one thing that we do is we just have a very convenient environment for other people to make packages with widgets like this. And then every single community can just make their own widgets. And we try to make sure that stuff that they would also like in the notebook, that just plays nice. But a lot of this heavy lifting is done by this library called Anywidget. But if you now were to go to the Marimo gallery, if people want to learn more about Marimo in different disciplines, I just click this geo button, and then there's lots of like map demos. So there's one where you can drag and drop GeoJSON files, one that shows all the airports out there. There's also this GPU rendering trick with DeckGL that you could do to show fancy hexagons. So that's the thing you could do. We also have a button here called STEM. And then we can explore more fancy things. So apparently there's, you said chemistry, right? So there's a...
Oh, hang on. There's one with a... Is that a MRI cross-section of a... Okay.
Yeah.
That looks interesting.
Okay, so I agree. So let's play. So we're going to play that one, and we're going to play that one. But one thing you can see right here is, okay, like, so we support image. So if you have a table, we can show images in it if there's a URL or like a good format. So, okay, we have a data frame table here with chemical structures and the associated image. And if you're a chemist, this is a lot quicker than reading this, right? Okay, so we have some things that work nice on that space. And then this is like, so we've got also like features where you get a matplotlib image, you can click and drag, and that's then a selection. That selection also updates the cell below, so that's stuff that you could do. Back to the MRI one. Again, this is a widget. One thing that's pretty cool here is I can click like a specific part of the brain, if I recall correctly. Awesome. But I can also zoom in on this axis, and you can sort of zoom in on a specific part of the brain, and you can see this XYZ coordinate also.
Is this using a GPU?
I think that this is using a library called 3JS, so it might. Okay. This is still a relatively lightweight calculation, though. I don't know. So, oh, there it is. So this is. I just clicked the button. That portion of the brain just got downloaded, so you could then have a look. Like, okay, that portion of the brain. Can we zoom it in on this direction? I can also click and drag and move, things.
Interesting. Let's try and link my wife and my discipline. Sure. So she works for a medical physics device maker. Sure. And they've got a partnership with another company that needs GPUs to run their software, but they have a challenge in finding a way to deploy a GPU-based system. For example, there's MRI-guided linear accelerator administered treatment for cancer. And it just got me thinking, because it sounds like Marimo, with the core having been acquired by Coreweave, makes it incredibly convenient to start using a GPU in your analyses.
So a few technical details on that one. So if you're in the medical space, then I can imagine, oh, we'd love to use a GPU for a few things. Maybe not one that's off in a cloud provider somewhere far away. It needs to be on premise. Like, if that's the case, then you do need a different conversation, right? You're not going to use molab for that. Yeah. Another thing is also, like, as far as the speed up is concerned, I think this right now is using the GPU on my Mac Mini, not the GPU on Coreweave. That's my impression, because the environment that I have right now has one CPU and two gigabytes of memory. So I'm pretty sure
that's not the one from the data center.
This is just happening in the web, right? So, and a lot of this stuff is also like data access. That's the thing that makes some of this stuff complicated. Like, oh, we don't want anyone on the internet to just reach these MRIs because that's super private data. Like, how do you deal with that? Usually that's also like a source of complexity when you're talking about deployments of this sort of a thing. Yeah. The main thing that I care about, though, is that if you have your own cluster and your own compute backend, that you are able to run Marimo there. And that, we try to make it easy for people to feel creative enough to, make apps like this. And then we would love those widgets to also work in Marimo. Something that we are working on right now, and this is very much in the, CTO has started work on it. We can play with it, not live yet, but like something that we can imagine is, it would be nice if you could run some sort of version of Marimo on your own hardware that also has some authentication to it. So you could sort of log into your own little Marimo hub, if it were, right? That's stuff that we've started brainstorming as well. But it's also, again, one of those things where we're 8 people, and it's hard for us to give promises or deadlines because, now this AI thing happened and we got to respond to that. That's also like a fact of life.
We're talking about the collision between a wonderful new, a bunch of bright minds and the archaic, dark corporate enterprise world.
Well, I mean, yes and no. Like, one thing so for this point in time of growth, one thing I can just mention, right? There's still, if I look at the download numbers of Jupyter, and if I consider the download numbers of Marimo, there's just so much runway where we can invest so much in open source, and that's just going to be so beneficial to Coreweave. Like, the incentives align perfectly there right now, right? I don't know if it's still going to be the same in 20 years. I'm not going to give you that guarantee, but at least for as far as I'm able to look forward, and if I assume that we want to be as big as Jupyter at some point, right? There's still so much stuff that we can do in open source land that will immediately be beneficial to Coreweave. So, at least for the foreseeable time being, I don't see like any concerns whatsoever in like that's particular space.
Yeah.
And also, Marimo is fully open source as well, right? So even if we couldn't even do a rug pull if we wanted to, because people can just fork it. And same thing with Anywidget. I think that's MIT. I could be mistaken. Marimo is Apache too. So the main thing, at least from my perspective, is I just want people to give themselves more creative freedom. Because you get a lot of like, oh, I don't need a special app for this. I can maybe just build something real quick in Marimo and I can play around. And that playful nature, that's where innovation happens. It's not when you're stressed because we need to build the system with these specs. Yeah. No, it's when you're just kind of free and playing around. And like my best ideas come from when I'm in the shower, having a coffee, like at the playground with the kid. Or watching this like Australian guy on YouTube doing plumbing, like Australia drainage cleaning services is an amazing YouTube channel. We talked about that for a little.
Everyone has their go-to destruction YouTube channel. How do we assist an individual to navigate out of the Esri ecosystem to using Marimo to start spontaneously, conveniently using a GPU and blow their boss's mind?
Right. Okay. So a few things on that. There's a book by Malcolm Gladwell called David versus Goliath. And it's a book with all of these stories where in real life, a actual David beat an actual Goliath. And it sounds like that's the situation in geospatial land. So that's what I'm reminded of. And the one inspiring thing that if you were to sort of draw a red line that connects all those stories, is that if you're a David, you win by playing a different game than Goliath. Like because you can do something that Goliath can't do, and that's how you win. Like you have to look for that thing that you can do that Goliath can't. And then if I think back about software, like I don't know, 15, 20 years ago, kind of when I got started, SPSS and SAS, like that was a software if you did statistics. But then at some point, you know, for every analysis you wanted to do, you had to go to the menu and you had to hit the button.
I remember. I used SPSS too.
There you go. But then you also remember, like, oh, but if that analysis that you've got in your mind, if that can't be done in that menu, if that button is not there, I need to do something else. But if you come up with a clever trick and you're able to show that that clever trick works and that the button in SPSS is missing, you've just beaten Goliath. And but a lot of that, and it's also just more of a personal core philosophy, a lot of that is not, oh, tool doesn't work. A lot of that is more giving yourself creative freedom. Like you should never feel like if you feel constrained by the tools that your vendor gives you, okay, then start using other tools. Like it's never been easier to open up a notebook and just play around with stuff. But if you don't give yourself the creative freedom, you're never going to get there. Like that. So that like part of that I think is more core than even something like Esri. I've never used it. I'm sure you can get data out, and if you can get data out, you can do it on a different VM that has a GPU and go nuts. And I just happen to know that a colleague of mine is now exploring how to get GeoJSON shapes in our little data frame thing as well. Again, one of those things, no promises. It's just something we're exploring. And, you know, we also had a quick discussion beforehand. I've heard apparently there's Geo support in Parquet now, which is an open standard. So, you know, there will be people working, and if Esri can move as fast as the rest of the world to make sure that everything you want has a button, you know, I'm assuming Esri is like SPSS. I'm sure it isn't, but you know, maybe
that's
it is.
Exactly really what Esri does is takes the need for a modern data team out of it, and means that a technician, and this is not to pour cold water on or to besmirch, to criticize those who are Esri technicians at all, but really, I guess the power of Esri's approach and their success is evident in the dominant position they have in the industry of putting buttons on what a whole modern data team would otherwise have to do and be employed to do.
I mean, so another thing there, and I don't know how red-pilled or blue-pilled your audience is. We also have agent support, right? So if you want to have Claude write your notebook, we've got some really nice features for that too. So like Claude can inspect, like Claude can move a slider on your behalf. Like that's the extent to which Claude can like interact with this notebook environment. So, and it also works with open code. You know, we try to support all the models out there. Like maybe another story that's because it feels like we need to move a little bit on the inspiration button on this one. Like when I got started, so people might not hear from my accent, but I actually live in the Netherlands. I'm Dutch. I lived in the US when I was young. So I eventually had a gig at the Dutch BBC. And like the ABC, I think it's called in Australia, I think, right? Like
Yep,
ABC,
that's
BBC.
right. Australian Broadcasting Corporation. Yeah.
Yeah, BBC has David Attenborough. You folks have Bluey, which is an amazing show. I'm a parent now. Bluey is the best. Like there's no Oscar big enough to sort of celebrate that show. It's like, Australia, well done. Like
we have a 5-year-old, and she's gone through all the episodes, and yeah, some of them are really touching for adults as well. Yeah.
Yeah. So my stance is it's actually a show made for adults that kids can watch too, as opposed to a kid movie that adults can also watch, which is what Pixar does.
There's
anyway,
2 layers. Yep.
So you make a recommender system, and at the time, TensorFlow was all the thing. It was all the rage, and there was a competing company with like PhDs in this stuff, and I was just there with like a little small data team trying to just get a basic recommender sort of going. And you can imagine a little bit of arrogance, like, oh, you're not even using deep learning, like with the cognac glass, like sort of. And then we said, like, okay, sure, but I think we want to have an A/B testing system before we do anything with deep learning. Because if you want to compare 2 algorithms, you have to be able to compare them in the first place. So why do deep learning if you can't even do that? And then they kind of said, like, yeah, okay, fine, I guess, because they could only do deep learning. It was like a Goliath. But okay, what's the game they can't play? Well, we know databases, so we did that. And then eventually, okay, so the recommender has like 3 slots where you could put recommendations in. They kind of already had a rule-based system. We were just there to improve it. Again, the deep learning people come back in and say, can we do deep learning now? And then we said, no, we're just going to do like AA test the system. Because, we don't, if we don't AA test, there might be a mistake in our like recommender system. We want to test for that too. Another week, can we do deep learning now? Oh no, because apparently the order in which the episodes are landing, like the order in which we do the recommendations, might have a large clickbait effect. So we just want to test that effect actually independently, if you don't mind. Like, okay, fine. Again, they came back, and this went on for like a good 2 months, and then eventually it got kind of angry and it's like, can we finally now do deep learning? And then we replied by saying, yeah, but we kind of noticed that when people watch a show, they're really keen on watching the next episode afterwards. So we're just going to do that as a recommendation.
Oh, no.
And again, like what I'm saying here is I wasn't Gandalf the White as far as like being an amazing programmer or anything like that was, but I did feel the freedom to just poke around in the data. And at some point you just see a very obvious pattern. Like people are actually clicking out of the menu to see the next episode because that's not what was in the recommender. And you can't make a product argument that says like, okay, but next episode should just be a button in the player. That shouldn't be a recommender, maybe. Like, good argument, all that, that's fine. But if we aren't able to change the player, but we are able to change the recommendations, well, But again, it's a lot about like, you can often keep it simple, but just give yourself creative freedom. It's usually like those little small ideas that you've explored in the notebook. It's honestly a lot of go to a bar, try it out in the notebook. If it doesn't work, throw the notebook away. But you want to have that quick scratch pad to just try an idea. Like that's the freedom. Yeah, that's what we want to make a tool for.
Yeah, and I think maybe just to tie it back again to what you said at the beginning, you have all of this freedom, a low friction approach to ideating, if you like. But I think what makes this exciting and interesting is that you make it convenient, easy, useful to use GPUs in this whole experience.
So molab, that's our cloud thing. It's a button click. So if I go to molab over here, you hit this button over here, GPU, you click there, save from the start. You also get like a fair amount of memory and cores, by the way, by default. Wow. Again, like we are playing the game of give people free GPUs, they said. It will be fun, they said. So while supplies last, we're able to offer this, right?
Sure. I love it because, I think people feel like, everything is supposed to be GPU powered these days, or you're supposed to be, to show that you're keeping up with the trends. You're supposed to show how, you've tried out to doing your analysis using a GPU. So I just love that this makes it easy to do in a spontaneous way.
I will push back on that just ever so slightly, also to make one sort of feature clear. This is a library called Wiggly Stuff, which is my collection of fun Anywidgets. So if you want to have a 2D slider where your X and Y coordinate can be moved around with a puck, let's say, I've got a widget for that. And if you want to have a matrix where every element in the matrix behaves like a slider, I've also got a widget for that. And what I can do is I can actually there's a button you can click and you can go to molab, and then this will load. It's loading up all the dependencies and doing the notebook thing. And you can see here, I've got a widget. When I slide this puck around, stuff just automatically updates. But this is happening fully in the front end. So not even a backend, like not even a GPU, but also just not even a backend, because there's a JavaScript trick that you can pull off to actually run Python in the front end by using Pyodide and WASM, and there's a pre-compilation trick that we're using under the hood here. But you can also do really amazing stuff without a GPU. It's also just a point I want to make, because you can make really compelling demos that run fully in the browser too, right?
Yeah.
So yes, we use GPUs when necessary, and they are increasingly necessary, you could argue, and not just for AI land, but also just geoscience land. Like if you want to do fancy things there, you need compute.
I guess why I don't want to over-index on it. I don't want to obsess about it, but in geospatial, there can be some really hardcore analyses. Like if you're talking about planet scale, raster data sets, for example, it's useful to have a powerful computing solution to tackle that stuff. So I guess and another frustration I have just from my own experience as an Esri technician, is that it really doesn't feel like they are properly deploying or utilizing GPUs, even on your own local hardware, let alone in a cloud computing context. So I wanted to emphasize how it seems like this is a competitor, an alternative to think about if you're trying to take a modern approach to your geospatial analyses. Without, with all the qualifications you're going to now add to what I just said.
Well, I mean, if I think about heavy compute things, things that come to mind from when I did I have like one technical degree as a industrial design engineer. Finite element methods, like those can be like so those can be a beast. Some differential equations with weather, those can be a beast, right?
Yes.
And then there's all the fun stuff with satellites, and then you want to figure out how much rooftop can I put solar panels on, and also not exactly hello world of computing. You actually some
have you heard of whereabouts?
Whereabouts.
Chuck them in Google. Whereabouts, where, and then WHEROBO. That's it.
Whereabouts.
Whereabouts. Yep, that's it. So they're like your go-to, modern geospatial, computing database platform, where they're about, reading the world, as it were, being able to query the world, and have a distributed spatial compute approach. That means that you can relatively spontaneously operate at a planetary scale with your analyses. So they also have a notebook type approach to running their platform. Essentially, I think at least lives in AWS, if not other cloud platforms. You can see the AWS marketplace.
AWS is all over the place.
Yeah. So I don't know. I feel like we're in the world of whereabouts in the mind of a geospatial person. Marimo lives under that category. And I can't help but think for your average, if there is such a thing, whereabouts user, definitely Marimo would be something of interest as well. So yeah, really amazing to have a conversation, Vincent, in this space. And I'm inspired. I want to use Marimo myself and see how far I can get. I recently got a Claude. I got the annual subscription, so I need to start using Marimo too. Let Claude loose in there.
So one thing, so if you're going to play with Claude Marimo, just know there's like a settings hamburger button on the side over here, and it says here pair with agent.
Awesome.
Basically, the way I like to use it, so I like to use Conductor because it makes it easy to have like one interface, and then all my Claudes and all my different agents are just in one interface. It's a GUI, and I can just copy and paste this prompt. And this has like all the settings. Like, okay, go to this URL. This is the token, and then your agent can just hook in. And it can be open code, it can be codex, it can be whatever you like. Just copy this prompt into your conversation, and I think I can actually show you. So pair with agent prompt. Conductor. So this is just my wrapper around Claude. There's like a ton of other tools, but I'm just going to open up a new workspace. So this is a conversation. I will be using Sonnet. There you go. I'm just going to paste that in. I could also do this from the command line, but if I were now to go back, we should see a toast appear at some point. So you can see this Marimo pair skill just got activated. Let's just only zoom in on the conversation there. It's going to test the connection. Connection confirmed. Now sending the toast. Claude has entered the chat. Make a cell that says hello world in Markdown. That's always a fun thing to do. And then afterwards, we're going to see if we can actually move the slider. Move the slider to be equal to 8. So added hello world. Yeah, okay, maybe this toast needs to go away. There was a, oh, there we go. This is the cell that it added.
Awesome.
There we go. Cool. Okay, so move the slider to 8, 5. I'm going to hit enter now. My hands are off the keyboard for a dramatic effect, but also to really show that I'm not doing anything weird here. We should see it click any moment now. Yep, click. There we go.
There we go. Crazy.
So the really cool trick here, like Claude can actually we use this virtual scratchpads trick where there's a REST endpoint and it behaves like a file, and Claude is really good at handling files. But that file lives in the Marimo context and it has access to all the variables. So normally Claude would have to like print stuff on the terminal in order for it to read output. Here it can actually say like, oh, let's have a look at the first 5 rows of a data frame before writing any code. So that's a really powerful trick, and it's like a pretty new one as well.
Okay. There's such an appetite, honestly, to break out of the Esri monopoly. So I'm sure I keep coming back to this to try to like light a fire.
Let me ignite the fire a bit more then. So right now, like we do this on occasion. Like right now, we are running a competition
awesome.
Together with the folks over at AlphaKai. This is one of those whoever can make the coolest notebook from an academic paper. There's still some time to like participate. You can win a framework laptop. We you know, some token from Claude Code. But we're really, I think the next edition of this it'll probably be more themed. So we might have like a physics theme and like a chemistry theme. I would love to have a geospatial theme. So if that's something that you can help organize, let us know.
Let's do it.
Because I think it would be really cool to see, like, oh, like what if the geospatial people have access to Vincent Discord and we will just sort of help you come up with like new widgets and stuff. Like that could be really cool.
That would be awesome. I'll have to get in touch with Troy Schmidt, who's in my network the one that uses Marimo the most. Awesome.
Sure. Okay. But yeah. In summary, this is Marimo. Go and be David. Fight Goliath. But most of all, creative freedom. Like try to like figure out a way for you to be more creatively free. And a final demo, I promise. Final thing I just want to show. I started writing software differently because of Marimo. And the best example is this library that I made called DiceKit. And I will also zoom in just slightly. Some people might be watching this on mobile. So there's this dice object in there. And one thing that I could do with that dice object, so I'm not into Dungeons and Dragons at all, right? But I can get 20-sided dice. And the funny thing here is that, you know, I represent that as like some sort of string, but I say, no, it's a chart because this is a dice with probabilities. And what I can do is I can say, oh, let's slider.value. Maybe the number of sides that dice has, that's something that the slider determines, right? Yeah. Okay, so I will call this a dice. Oh, what happens if I do that dice, but I roll it 3 times? Like, oh, wait, actually, I should do plus here, sorry. Okay, you get a totally different distribution to come out. Oh, okay, that's actually kind of interesting. What I can also do is there is this ordered function. So what I can now do is say ordered. So I'm going to roll that dice 4 times. And I have to pass it in like this. So I'm going to roll that dice 4 times, and the highest value dice has this distribution. The second highest dice has this distribution. The third highest die has this distribution, etc. Oh, and if I want to have like the top 3 of them, I just grab the first 3 of them, and then I can do a sum over all of them, and that now looks like this distribution. I mean, it's just so much more fun.
But I'm trying, as you go through this, I'm trying to translate this into how a geospatial analyst would think, and I just love how interactive and how useful it is for spontaneous ideating, and you don't have to wait so much. You see the immediate results in the cell as you're going, and I feel like this could speed up work in geospatial. Yeah.
And I still have that slider, so I can say like, oh, what if this is a 20-sided dice, right? And it's just there used to be this thing that people used to do called like domain-specific languages. They have like a very specific language for a use case. Like R was a stats one, right? Yeah. But here you can make a domain-specific environment, and I think that's more the powerful thing, because you can combine it has to be Python, like that is a constraint, but anything else on top of whatever the browser can do.
Yeah.
Right.
Yeah.
So again,
Python is like the foundational language for geospatial. So yeah, no issues there. Okay, well, we had a bunch of calls to action there. I feel like it's worth putting some effort into getting a geospatial competition up on this platform. So yeah, I'll do what I can. Talk to.
Yeah, we'll be in touch. But yes,
yes, we'll be in touch.
but also every geospatial person out there, we have a Discord, we have a YouTube. I do lots of demos there.
Awesome.
We also have a Reddit, so if people want to share cool widgets there, that's also super cool. And we are in this really cool little growth phase, like small team. We move fast, so if there's like things that you might need, we are there to help. And we want to make interactive notebooks super fun. And final comment, also with the whole agentic thing, I have found that agents work so much better if I can actually play around with the stuff that they're doing and if I can actually look at the charts. So I don't trust Claude anymore unless it actually produces a Marimo notebook as an artifact, because then I can see if it actually downloaded the numbers or if it just hallucinated some numbers.
Ah, nice. Okay, so you can see actually the basis for its outputs. Perfect.
That, and also remember that you could ask Claude to make a specific widget just for one analysis. We're not 100% there yet, but like some of the widgets where you can like, oh, I just want to be able to like draw an image and pass that to Nano Banana. Oh yeah, that it can do. So I have this Microsoft Paint widget that looks like Microsoft Paint that I've generated for this one analysis at one time. So like, there's also a lot of creativity still to be had in that domain as well. So that's the only thing I want to say. So if you have a Claude account, this is something you might want to play with for that reason.
Okay, awesome. All right, I feel like we could go on and on. So this has been a great first encounter, at least Vincent. And I do have a cheesy last point to make.
Go for it.
Look at what choosing the right keyboard can unleash. Vincent, you're a fantastic example.
But also there, like the really cool thing about the ergomechanical keyboard subreddit is also because there's just a lot of people being creative and making the weirdest keyboard ever, right? And like that keyboard right there. If
it's useful, who cares? That's the point.
So the circle is round now because we're landing where we started.
That's right. That's right. See, I'm a master host.
Yes. Okay. So close to the camera. This is the cyborg imprint, right? And you can see there's a fancy trackball, and so you hold your hand and you have your thumb key, but you can also move this trackball around. So you've got a mouse embedded on this guy.
Wow.
It's wild. This is it's got a 3D printed case. It's like I think the guy's in Wisconsin, one guy in the US. This is sponsored, by the way. It is a bit of an expensive board, but the thing that's really cool about it, he can make this for you, but he needs a photo of your hand.
Yeah.
Like you need to have a credit card under your fingers, put on the wall, and then he will make sure that this fits your hand like a glove. Like the distances between the keys, he has a program to do this, right?
Sick.
Yeah, sick, amazing. Not for everyone, to be very clear, but anyone should be able to applaud the creative freedom there, right?
Yeah. This is brilliant. Keyboards go deep. All right. Once again, Vincent, you've been amazing. I think everyone is now hammering away in Marimo as we speak. So yeah, great work. Appreciate it.
My pleasure.
So this episode is exactly why I run the podcast. What an amazing, inspiring, and enthusiastic guest Vincent was. So let me share my screen. So what we have here is a Marimo notebook on the right, and a Claude Code tab in Visual Studio Code on the left. You'll recall from the video, Vincent said that we can connect or pair a Marimo notebook with an agent like this. So what I dutifully did was I went to the prompt tab, I hit the copy button, and then I brought that over on the left into Claude Code. I won't run it again because I already have. And then I started to do what Vincent demonstrated in the episode, where he said, modify, the slider setting in the Marimo notebook. What I noticed was that there was some confusion. It instead updated the value of the slider in the preceding cell. And then no matter what I did with the auto update settings or auto run settings, in fact, the slider itself down here didn't change. So then I did some Googling around and I found this GitHub repo specifically about Marimo pairing. So I just directed Claude Code at that URL here, and basically I said, make it work. It began then to actually interact with all the elements. So let's demonstrate that here. You can see currently that first slider there is set to 1. So let's say in Claude Code, move first slider to value of 10. Let's see what it does. There we go. You can see we've got 10 little emojis there and it's set as 10. So just so amazing to see this live connection. Effectively, you can talk in natural language to an agent through the pairing with a Marimo notebook. It will do what is necessary in the back end, as it were, or in the syntax of the Python file that ends up rendered as this Marimo notebook to change the position of that slider. Amazing stuff. Now, this is a geospatial podcast, so we have to do something in geospatial, right? So then I saw a mention of leaf map here. So I then simply grabbed that URL and again put it into Claude Code on the left. And I told it to make leaf map work and add a map zoomed to Serbia, where I am right now. After some back and forth, it had to restart the notebook. It did that. It was positioned correctly like that. And so then, of course, what I wanted to have was the same interactivity between the slider and the map, because that's what this whole demo seems to be about. And it put the slider first. And then as I move the slider in and out, you can see the map responds if I put it all the way in or all the way out to the world. So, this is a basic demo. Nevertheless, quite compelling.